Okay, so in this video we're going to go over how to graph in slope y-intercept form. Remember, slope y-intercept form is y equals mx plus b, where this is our slope and this is our y-intercept. Now, it's important to know those because of the fact that when you graph a line from slope y-intercept form, you're going to start with the y-intercept and then you're going to use the slope to calculate your next point. It's easiest to start with one that looks a little bit more complicated. Let's examine the line y equals 2 over 5x minus 1. Oh, hi Rowan. Okay, sorry, bye dog. All right, so we'll start at our y-intercept. B is -1. So we'll plot that right there. We'll then use our slope. This is the rise, and this is the run. Now the rise is going up vertically, and the run is going across horizontally. So we have a rise of +2. From our first point, we'll go up 1, 2, and we'll go over 5. 1, 2, 3, 4, 5. So this creates a triangle that has a height of 2 and a base of 5. And we in fact have our first line graphed. So this is the line y equals 2 over 5x minus 1. And I think that my label might have fit because my dog saved us here. Also showed off my daughter's toys. Okay, we'll take a look at our next line we're going to graph because it's going to get a little trickier. So our next line that we'll graph will be y equals -3x plus 4. Again, we have the same routine. We start at the y-intercept. So the y-intercept is +4. That's our starting point. But now our slope doesn't really have a rise and a run. It just has kind of one point. Well, any number divided by 1 is just itself. So we now have a rise of -3 or down 3 and a run of 1. So that gets us from this point, down 3, and over 1 to this point. Once again, I'll connect the dots. Pardon me as I lean in. And so this is the line y equals -3x plus 4. Great. Now I know my ruler kind of slipped a little bit here, but it's important to note that negative lines will rise toward this quadrant, and positive lines will rise toward this quadrant. Let's take a look at yet another example that's just getting a little bit more complicated now. And back comes my dog for more. Rowan, out, out, out. It's okay, buddy. I'll get you later. So the first line we're going to take a look at is a line like y equals, let's go y equals -3. Now, this is not a line in slope y-intercept form. Well, not exactly. Remember, slope y-intercept form is y equals mx plus b. But here there's no x term. So obviously, our value of m, or our slope, must be 0. Well, a line with 0 slope is going to be perfectly horizontal. Another way to think about it is, here's -3. That's where y equals -3. Other points that have a coordinate of y equals -3 are all at the same height on the axes. So they're all going to be these perfect horizontal lines, or horizontal points, and they'll be connected by this line. So every point along this line is going to have a y coordinate of -3, which is why we call it y equals -3. So I know it seems like y is a vertical axis thing, but because it's holding the vertical amount fixed, it's going to leave you with a horizontal line. Our last line that we'll take a look at is another similar one, but it's a line like x equals -2. Now, this one is different for a whole host of other reasons, but it has the same concept. Here we're saying, let's fix the x coordinate to -2. So we want to make a line with every point having an x coordinate of -2. Again, you'd think x would be horizontal, but here x is -2, here it's -1, here it's -3. Only along this vertical line is x equal to -2. So that is our line x equals -2. And that's just a quick review of graphing in slope y-intercept form.